Joao. It's our project, 6S initiative, is about space education and global networking of ground stations. I have some difficulties in English, but sorry for an error or imperfections. However, I believe we have another language in common here, is space science. Okay, it's our brief. Right, 6S, the project's components, impact, technical feasibility, risks analyzing, and the project evolution. For me, some important questions. When you decided to follow on the aerospace career? What's your inspiration? I believe every people present here at Takeda Hall had great inspirations in their lives. I have a great inspiration, a book by Arthur Clarke, The Man in Space. In function of the Arthur Clarke, I'm a space engineer. And 6S is a project to create inspiration in children, students, and graduates. Our vision is this. 10 or 11 years old, we have engineer. If you have a great ability, a great skill to disassemble things, disassemble gadgets, but not a great skills to assemble it, you is engineer, or you are engineer, sorry. What's your proposal? Equipping ground schools and colleges with low-cost ground station at a global level. Most schools in the world with a ground station, using the access to satellites and educational tour in large scale. Not only universities, right? Schools, houses, clubs, ever students. Create a global network of space education in different levels of skills. It's the project components. We have two segments, technological segments with a transponder, 6S transponder, and a 6S ground station. And another segment is educational, with materials, pedagogicals, website support, and documentations. All segments is important to the success of the project for me. How can 6S help teachers and students? 6S is learning tools. For me, robotics educational is a great benchmarking. Now, students are introduced in robotics, are introduced in large language program, in renewable energies. How not introducing in space technology in their daily life? It's, for me, a good idea introducing basic concepts of engineers in the first years of the education. This is the major component of the project, a 6S ground station. 6S ground station is different than another ground station because it's easy, it's simple, plug-and-play philosophy, needs no special skills for your installation, and has a target, ambitious target of price below $800 at 300 United scales is important for the project. A great industrial scale for this hardware, I think. It's the block diagram of the ground station is a simple transceiver and microprocessor module by interface and servos for antenna tracking is an option. It's most codes components, simple, industrial scale is the key words. A proposal of connected USB, TCP/IP, 6 ground station have two modes of operating, local modes and remote modes of operating. It's my dream. It's my dream. Targets of 300 ground stations in 5 years. In other words, big constellation, not by satellites, but by ground stations. Inverted equations. We think in constellations of satellites. We think in constellations of ground stations. Typical problem, a typical problem of communication and a future possibility. This is the near real-time concept. We can track airlines around the world in real time. We can tracking ships at the seas around the world in real time. We're not tracking CubeSats in real time around the world. Telemetry, telecommands, and payload observing in real time. It's the transponder. Transponder is a preliminary specification. 6S has a common modes, is a beacon, is a transceiver and transponder, and time master and Doppler shift for some experience about orbital parameters estimative. I started ramp communication, and I think in some modes, minimal modes of telemetry and telecontrol, is not only a transponder, it's a transponder and a minimal redundancy of telemetry and telecontrol for several events, failures. What's the hell for a satellite builder? Several events of failure in orbit. 6S transponder has these modes for some situations. The mass dimensions are only speculative, and this technical question is open in this phase. The target is 10 transponder on satellite partners in a decade. It's the proposal preliminary of the connectivity by transponder on CPU interface, board and computer interface, some IOs for minimal modes of telemetry and telecontrol, and for analog channels for minimal modes of telemetry. The impacts of global society for the students. 6S is introducing in the space technology. It has a stimulus for careers, a stimulus for new and creative experience. For teachers and professors, 6S as educational tools. For CubeSat designers and builders, it's a turnkey ground segments, a global tech network, a hard standardization in telecom system, and near real-time tracking telemetry and telecontrol. For governmental and private satellite programs, is a real-time and limited telemetry and telecontrol, some redundancy for serious events failures, and a polish approach because the educational use. For all, the impact is a widespread diffusion of the culture of small satellites in right schools and graduated schools, new vocations for aerospace, a global network of ground station, and a cost reduction for a CubeSats program, according a ground segment cheap and available. For me, a global network is a great window of opportunity in 4 years. If we don't do it, another will do it in the next year. I believe in this. Let me introduce my partner, Marcello, with second part of the presentation.
Thank you. So now we move about the feasibility of the mission, the study of the mission. So our approach was to divide the huge ideas of Joao in 3 steps. The first step is to simplify the mission. I mean, there are a lot of stuff to do for create this network. So the first thing is to write down the primary requirements of the mission and analyze it. The second is to write down the nice-to-have requirement. I mean, all the things that can improve the mission, but are not necessary. And the third part is to meet the primary requirement in the design. And the first step is the phases where we are in this moment, actually. The second step is make the basis. I mean, build the prototype of the system, test the system, and eventually go for a first mission if it is enough. The first step is go to meet the nice-to-have requirement, build the finished system, and go for the distribution. So when I talk about the simplification, we need to take in mind the mission that is to provide a very simple ground station even for primary school. So it means that we need just to collect some data and read in our ground station in a way that is understandable for everybody. So all that is not a primary requirement is nice to have, like for example also the uplink and also to have the servo antenna, because maybe for a primary school it's not required to have an uplink. So this is an overview of the first primary requirement for a ground station and space segment that we identify, but there are more others of this. For example, collect data from space, low-cost system of the shell components, plug-and-play standalone solution, like system, simple interface, reconfigurable system for the ground station is mean that it can be used to track different satellites, just changing the antenna. So this is how to do, but very general about, for example, how to take the position maybe with the space GPS module, the attitude using also magnetometers, gyros, and others, sensors that now are very cheaper on the market, also thanks to smartphone and the technology that is every year more little. And also we need to storage this data in the memory. And for what concerns the ground station, we need a receiver. So if you start just with a receiver and not with the uplink, there are a USB solution that is very affordable, especially if we want to distribute the ground station in primary school. It will mean that it's a commercial, and it will mean that we need to work on the interface, on the software, and the data output. For example, I can imagine in primary school, a child will just see the satellite, so it's possible to give a 3D representation of the satellite. So this is just the analysis of this requirement that we talked about and the issues. So this is the part regarding the space segment. And a space segment like that transponder have almost the same problematic that can have a small satellite in the developing. Because, for example, we have the standalone solution, plug and play. It's been that you will have a battery that is not sufficient to cover all the missions. So you need an external power, maybe from your host satellite, and maybe go for your own solar panel. But of course, it means that to have these things, you need to talk in advance with the designer of the satellite that you will host your transponder, because you cannot join in after the PDR, for example, or just before the CDR, and give, I need just also the power supply. This is not possible, of course. Also, the radio transmission is a big issue because if we attach our transponder to another satellite, maybe our transmission can jam the transmission on the big satellite. There are also other concerns that is the E2 rules that need to respect it. And so maybe for this, a possible solution can be considered to transmit our data through the satellite. But again, to do that, you need to talk in advance with the developer of the satellite. Again, also the integration. You must be sure that it will not affect the host satellite design. And it's not possible to have a standard transponder in this case, because you need to design every time. And also the system need to resist to different vibration profile, because you don't know what will be the launcher and will be the other issues related to it. So another big topic is that to keep the low cost of this space segment, because it's very simple overdrive the budget, and is need to try to find always the best cost-effective solution. So, for example, the solar power just for the transponder that we talked in before maybe is not possible because it can be very expensive. Also, to choose not subsystems that are not qualified, that are not qualification for flight. Maybe this can be not a problem, but can be. I mean, in a lot of CubeSat is used a lot of commercial components that maybe are not tested in the space. Some work, some not work. So this is not possible to know before. And this is the same for the off-the-shelf component. It's not possible to know before what will be the orbit of this satellite. I mean, to design now and in 5 years go to a satellite, you will not know the orbit, so you will not know the condition and so on of the satellite. So for this, a good solution can be go for a CubeSat mission to be hosted by a CubeSat because you are in low or very low orbits that could allow to use less shielded electronics. Short mission duration is an asset also for the electronics because maybe if I know that this mission will have a lifetime of 1 year, I can choose a component that is survive for 2 years because the third year I will not anymore in orbit. And a lot of CubeSat don't have a payload and are looking for that. I mean, there are a lot of enthusiasts on the CubeSat, but not everybody know what to want to do with the CubeSat. So maybe this can be a suggestion to host our transponder. But of course, you have a short duration of the mission and not constant coverage between the launches. So, I mean, maybe I find a CubeSat now and another CubeSat in 5 years. So where will be the network? And you have also less possibility to fit in the satellite because it's small and maybe it's difficult to find somebody that will give to you what you need. So for this, maybe a crazy idea in the space segment can be build a CubeSat or a pocket cube that some are launched just a few days ago. Are very little but can fit all the components of our transponder. And the complication to develop 6 space segments is similar to the complication related to develop this kind of satellite. And this satellite maybe could be built from kit in the schools, maybe in the university, so you can provide much educational aspect. And maybe the launch, because it's not so expensive, could be provided by the government that want to improve the space study in their country. For what concerns the ground station, it's much more simple because if you don't go for uplink, you just need to connect your SB receiver, and a lot of your work will be on the software. That is mean that to need very simple, especially for primary school. So maybe another issues of this can be just to create different software. If you for primary school, high school, university, and with the different complication, because maybe children don't want to see all the numbers, not just the satellite. And the only most complicated is just to have a reconfigurable ground station for cover much more satellite. So ground station should be more simple to realize, and you need to keep in mind that the operation capability of the ground station will depend from the software and from the user of the software. And the ground station should be able in grade to catch the frequency of other satellites, and maybe also meta satellite. This is nice to have. So in the future, it would be nice to have an uplink system to communication from ground station, for example, for Brazil and from Japan, just to send hello, how are you, and just to retransmit to the second ground station. The antenna with the servos, and maybe some idea like sonification and collected data and share with the application in internet to involve much more people. So the future, complete the first step, talk with possible partners, government, CubeSat mission, etc. Complete the second step, look for international agreement, first distribution, meet the next 12 phases, and the second distribution. For when concern our collaborative effort, we have a lot of exchange of experience because Joao is very expert in telecommunication, and we are not so much. And there are increasing of network for future collaboration and cultural exchange. So thank you for your attention, and thank you for all the organizers that allow you to be here together, and this is all.
Thank you very much. Now we have a time for the question.
Thank you. I think if you want to involve many schools and many ground stations, you must use the same frequency on your transponders on the satellites. And I don't think it's a big problem if you have a transponder on a certain satellite, because most satellites only communicate maybe 30 minutes per day with their own ground station, and the rest of the time they don't really communicate. So you can disable the transponder if you don't want the transponder to interfere with your own communication system. So I don't think it's a major problem on most satellites. There may be satellites where it can be a problem. My question really is the $800 cost. How was that estimated? Did you make any calculations or looked at typical costs for development of this type of ground station equipment?
Okay. It's true the question about the interference. However, in this project is necessary deployment similar philosophy than cellular phones. Cellular phones have similar problems. A new frontier of the telecommunication for CubeSats, I think. About the costs, it's a target. It's a similar right-tech gadget. I think it's most difficult precise estimative of the cost without a precise estimative of the industrial scale. In this moment, is only a target.
Yeah, for me it is not quite clear what you want to do with the system and what you can have, you consider to be nice to have. I'll give you an example. If you want to have a real-time connection between Brazil and Japan, it's different from having it just sent up, stored, and dumped down later on. These modes which you allow have a big impact on the number of satellites and the number of orbits you need to know, you need to have to make it happen. What is your approach to that?
Okay, for what concerns the real-time issues, I think that what Joao mean in the presentation is that it's possible to if you take a CubeSat like target, is just to have a lot of ground station that you can track this object in real time. I mean, when you have a lot of ground station, you can intersecate your receiving window, and in this case, you can know in each moment where is exactly the CubeSat. So just not to wait for him that pass on your head, but just also if this ground station are connected together, you can share the information with the internet, with the server. So in this sense was the real-time tracking. And the second part of the question?
It's not a message service. It's just to look for where is the satellite and what is he doing.
Yeah, exactly.
Okay, and then you can go with one satellite, but you can have also a constellation, whatever is feasible to implement your system on a satellite.
Yeah. Like he said, the concept of constellation is more for the ground stations, not for the satellite.
Other question? A question from the viewers out there? Okay, is there any question from the audience? We can accept one question from audience, if you have. Okay, no questions. Thank you very much for the presentation.